this is the first part of chapter 22, really talking about the history, the people, and how Darwin came up with the theory of evolution by natural selection. So before Darwin, we had God creating all the different animals of how we see them today. But then in the fossil record, we are finding all these animals who didn't exist anymore. So this is an observation. Another case, we see a whole bunch of animals who are extinct and different variations of when animals started coming around. And so Earth formed 4.6 billion years ago, and since then we went from bacteria, these trilobites, dinosaurs, and this is woolly mammoth over here. So Charles Darwin came in. He was there 1809 to 1882, was a naturalist, and he is the one who proposed the idea of evolution by natural selection. And he collected a ton of evidence in order to support his ideas. How he did this is it started with his voyage of the Beagle. He went around the world. This is the ship he went on, and it was led by Robert Fitzroy. He was 22 years old when he did this, and he made tons of observations. He was a naturalist, that's what you do. The main mission was to chart the South American coastline, so they were going across there. They stopped in the Galapagos Islands, right over here, so it started in British, mapping the coast of South America up here, which is about 500 miles off the coast of Ecuador. And among many other things, Darwin was fascinated with these armadillos. So they're native to the Americans, and most species are actually found in South America. And so we also found fossils, or he found fossils. So he's trying to figure out why the extinct armadillo-like species were with the living ones, all on the same continent. Why would there be similar things? Why did they go extinct? What's going on? And so here you see a giant ground sloth and the modern sloth. So we have the dead and the living. Again, looking at throw more light on the appearance of organic beings on Earth and a disappearance from it. He also found a lot of unique species. So the marine iguanas, Galapagos tortoises, blue-footed boobies, the finches, all kinds of finches, and he collected many, many birds. So many birds. He collected all of these guys, and he thought they were different kinds. A finch, a sparrow, a woodpecker, warbler. But what he really found was a lot of finches. So he was amazed to find out that all 14 species of birds were actually finches. They're all different finches. But there was only one species of finch on the mainland. How did one species of finch become so many different species now here on the Galapagos? So he started thinking and drew up this tree of what things could look like. Ancestral species to the descendants. This says up here correlation of species to food source. So you get your seed eaters, flower eaters, and insect eaters. This is called adaptive radiation. So depending on the food that they eat is what they went through. This is a rapid speciation because they're filling new niches because they inherited successful adaptations. And again, they inherit it. They're born like this. All the differences are in the beaks. So it's associated with different foods. So if you're born with this bigger beak, you can eat some of those bigger seeds. And then the survival, you're able to survive and reproduce, which is good for that island. So if your island has cactus versus a lot of trees and insects, you're gonna whoever has the best adaptations are going to be able to survive and reproduce. So what Darwin came up with is that these small populations of the original South American finches landed on the islands. After that, the variation in beaks enabled individuals to gather food successfully in different environments. Over many generations, the populations of finches changed anatomically and behaviorally. The accumulation of advantageous traits in a population made a new species. So seeing the graduation, and diversity of structure in one small, intimately related group of birds, one might really fancy that from the original paucity of birds in this archipelago, one species has taken and modified for different ends. Again, just basically saying all these birds came from one. And the differences allowed some to successfully compete, successfully feed, successfully reproduce, and they pass those successful traits onto their young. So depending on what they eat, and you can see all of the little pieces in here. And so same thing is happening with these Galapagos tortoises. And so you have the different pieces, what they're able to eat. So you have a shorter neck, and they can have things that are close to the ground. They also had different local variations in the morphology. So depending on who they are, so maybe the first step of splitting one species into several, and so depending on where they are for things, they look a little bit differently. Another piece is artificial selection, and so this is where you purposely change everything. So all these things you see over here come from a mustard plant: broccoli, cauliflower, Brussels sprouts, kale, and cabbage. It's not just a process of the past. We still do it today. So you can see, okay, that last kohlrabi is the last. Okay, so you can see all the different parts of where we would get this plant. We selectively breed and turn them into all these different organisms. Obviously, one of the biggest things that most people can think of is with dogs. So we select what we want. So you get all these different types of dogs: big dogs, long dogs, cute little long haired doggies. So, going back to the historical content, you start with everything started with Linnaeus, who categorized everything, and it kept going. Notice Lamarck had evolution way before Darwin. We'll talk more about Lamarck and these different people who are doing different pieces. And so, some major people, Malthus, and he believed that competition is when you have a struggle survival, the population growth is going to exceed the food supply. Principles of geology. This showed us that there's land masses that change over really long periods of time. So, Darwin returns back to England and wrote a lot of papers about his collections and observations. He did a ton of work on barnacles, and he had a draft of his species formation in 1844. So it took him a little bit, but he got it. He instructed his wife to publish the essay upon his death. He didn't want to publish, but he also didn't want the ideas to die with him. However, in 1858, he received a letter that changed everything. Wallace came around, and he was from the East Indies, and he wrote a short paper with a new idea. He asked Darwin to evaluate everything, as scientists still do today, and then he was going to go ahead and publish. Well, this is what Wallace came up with: the tendencies of varieties to depart indefinitely from the original type. Sounds a lot like natural selection. This is Darwin's The Origin of Species by Means of Natural Selection. Preservation of Favored Races in the Struggle for Life. Well, Darwin didn't want Wallace to get all the credit. So, as he wrote to him, your words have come true with a vengeance. I never saw a more striking coincidence. So all my originality, whatever it may be amount to, will be smashed. And so on November 24th, 1859, Darwin published On the Origin of Species by Means of Natural Selection. So his ideas is that variation exists in populations. You can see that everywhere. There's an overproduction of offspring, more offspring than the environment can support. There's competition, food, mates, where you nest, how to escape predators, and there's differential survival. And so some are going to survive, some aren't. And those successful traits, the reason you survive is because you have adaptations within you. There's also differential reproduction. So more adaptations become more common in the population. If it's advantageous, it becomes more common. Going back to Lamarck, so we're kind of going backward in time, just so we can compare. So what Lamarck believed is that organisms adapted to their environment by acquiring traits. Like we talked about, hey, I want to be taller. I'm going to be tall. And that you can change in your lifetime. Disuse. So you lost parts because you didn't use them. So if, let's say, my left hand is useless, which it is, it can't really do much. If I don't use it, it's going to go away. Missing eyes, and the digestive system of a tapeworm. He didn't use it because he sucks off of us, so it gets gone. It leaves. And then you get perfection with use and need. Constant use of an organ makes it increase in size. The muscle of a blacksmith, large ears of a night flying bat. And you can transmit those characteristics to the next generation. So, the giraffes, in reaching higher vegetation, giraffes stretch their necks, and the acquired neck went to the offspring. Not exactly how it happens. Darwin believes those that were born with a longer neck are going to better survive, leave their offspring who will inherit their long necks. Cha-ching! And so, this just shows how life has changed over time, starting way back. We have some bacteria, and we get into now with our mammals. And again, showing kind of same thing without the pictures. And you can see that as the environment changes, different organisms will come as well. And this is just a famous quote: nothing in biology makes sense except in the light of evolution. If we don't say that animals have variation or are changing, then the rest of biology doesn't really make sense. And we'll be talking more about this in class, so ask if you have questions. Thank you.